Hello, welcome to lesson 5. As you can see, I'm in the library today because the internet is down on our end of the building on the day that I am recording this. So I have come to the library. You might hear some noise behind me if people are moving around. But let's get started with lesson 5. Lesson 5 is modeling with linear equations. So it's just word problems and breaking down the information in the word problems to get to how to set up the equation and then going through the steps of solving it once you've set it up. So I'm not going to do a whole lot of notes on this one. This is more of a thinking and independent practice type of skill. It just takes some time for you to work through. So I'm going to go through these steps here with you and then do exercise 1. After that, you'll be on your own for the rest of the notes, and then we'll check those when you're finished. So when you are looking at a real world scenario to solve involving equations, you're going to go through these steps here to make sure that you're getting all the information that you need and using it appropriately. So step 1, clearly define the quantities involved with common sense variables and let statements. Let statements just means like let X represent blah, blah, blah. So whatever information is in the problem, use common sense variables. So like if the problem's talking about money, maybe use an M. If it's talking about seconds, maybe use S. That's what it's referring to with common sense variables there. And then number 2, pay attention to the units in the problem. Are we talking about feet? Are we talking about dollars? Are we talking about people? What are they looking at? What are your units in the problem that will help you model the situation? Then use your let statements to write out expressions for the quantities that you're interested in. So looking for those clue words that might give you some indicators for operations, write out expressions. And then carefully translate the information you are told into an equation with the help of units. So translate your information into an equation. That's the main goal here with modeling with linear equations. Finally, solve the equation and then check for reasonableness of your answer. If you're supposed to be solving for like a number of people and you get a fraction or a decimal, your answer you probably made an error in either setting up your equation or solving your equation in some way. So if your answer seems unreasonable, that may be an indicator that you've missed something somewhere in there. Let me clear the screen and scroll down a little bit. So now let's dive into exercise 1 as an example of this process. So Keyshawn is modeling the amount of money he has left at a theme park where rides cost $4.50 each. He started the day with $65, and after taking a certain number of rides, he has $29 left. He is trying to algebraically determine the number of rides he has taken if he only spent money on rides. So the information that they have given you, let's go through and highlight that information. So he is determining how much money he has left, amount of money he has left at a theme park, and rides cost $4.50 each. He started the day with $65, and it says after taking a certain number of rides, he has $29 left. So the certain number of rides is what they're trying to figure out. He's trying to determine the number of rides. Determine the number of rides. That's going to be your variable. So a good choice of a variable for the number of rides Keyshawn has taken, I'm going to use the letter R. So let R equal number of rides. That's your let statement. Going back up to your steps up there in that box above. All right, it says give an expression involving your variable from A, so the variable R, for the amount of money Keyshawn has spent on rides. So money on rides goes back up to where it says rides cost $4.50 each. We don't know how many rides he's done because we know that that's R, but the expression for how much he spent on rides would be 4.50 R, $4.50 per ride. So 450 times R. And then for B, using the information in B and the information from the problem, create an equation that represents this situation. So they told us that he started the day with $65. and every ride he rode is going to deduct money from that. So we're going to use subtraction, and then we know that it's $4.50 every time he rides a ride, so $4.50R. And they told us how much he has left at the end of the day, which is going to be your equals. He has $29 left. So here's your equation to solve. It says, and solve it. So I'll pause the video here and let you solve that equation. All right, hopefully you've solved this equation for R and should have gotten R equals 8, which would mean that he rode 8 rides in that day. There's the bell. Let me finish up this video. We're just going to do one more section, and then, like I said, you're going to do the next 2 exercises on your own. All right, so we got R equals 8 on our last one. It says, later in the day, Keyshawn notices that he now only has $10 left. Is it possible that he has only spent money on rides? If so, how many? And if not, why not? Well, we knew that he had $29 left at 8 rides. If he now only has $10 left, then that means he has spent another $19. So if rides cost $4.50 each, you could set up just a simple division problem. 19 divided by $4.50. I got my calculator handy beside me. That comes out to 4.22 repeating. Is that reasonable for the question at hand? Has he only spent money on rides? This would mean that he's ridden 4.222222 rides. Is that reasonable? I'm going to pause the video here, let you answer that question, and then exercises